I'm making my own MSLA printer based on the Arduino code, and it should be an awesome project, so you might want to stay till the end. After a lot of testing, I finally made the PCBs that I wanted. One PCB for the UV light control, one for the TFT display creating the shapes, one PCB for the main control, and one smaller PCB for the buttons and the display interface. I've also designed a 3D body for the printer, but I haven't assembled the printer yet. So in this video you'll be the first to witness how it goes. I want to assemble the PCBs and give them a test and see how the code is running. If everything is okay, I assemble the final printer and get a final product. As you can see, this is a complex project and it requires a lot of components, so at any time things might not work. So guys, let's get started. What's up my friends, welcome back. This project is coming for a long time and is quite complex with a lot of components, motors, displays, PCBs and a lot of smaller other parts. For now I have these 4 beautiful PCBs designed for the MSLA printer. If you remember, my first tests were made with a smaller TFT display of only 128 pixels. But this time I will use this 4-inch display with a size of 90 by 60 mm, so it's a lot better. This PCB will hold the screen in place, and also an end-stop switch. This other PCB is the main controller, and it will have the microcontroller and the drivers. This other PCB here is for the ultraviolet LEDs, and it will get on top of the main PCB. And finally, this small PCB is for the buttons control and the OLED display. So if you want to try this project, download my Gerbers from below. Then I go to PCBWay.com and click the Code Now button. For each PCB I insert the size and the amount. In my case, for the color I select the black one, which is my favorite, and PCBWay makes them very nice. On the next page, upload the Gerber files that you have just downloaded from my website. Place the order and I receive the PCBs in just a couple of days. And they look amazing as always. So now we have these 4 PCBs, so let's begin. This is the UV light PCB. It has the pads for 18 UV LEDs like these ones. And because this will dissipate a lot of heat, on the other side I've designed the PCB with exposed copper. And to limit the current we also need to add some power resistors. So I get the LEDs and the resistors and solder them to the PCB. And now the board is ready. I test it with my power supply and it works quite well, and using 11 volts it draws 1.6 amps of current. Having so many LEDs, we assure that we will have a more uniform light below, so the resin would solidify uniformly. Next I solder the display PCB. But before that we need the display. So get a module like this one, and we need to remove the red PCB and the backlight. First I remove the LCD from the PCB module. It's just glued in place. And be careful not to break the LCD. Open the metal case and remove all the white sheets and the LEDs. You should end up with just the screen module. And now we have to solder this to the screen PCB. It has this flat connector of 48 pins. One soldered in place with the screen and the PCB flat on the table. On each corner I solder a piece of solid wire and press them against the display, because this will hold the screen in place. And on the top side I also add some Kapton tape, and that's it. On the bottom side I also add this connector for the flat cable. I add that flat cable and this PCB is done for now. We have the LED board and the display board as well. So next is the main control board. To assemble this one we need an ESP32 like this one. We also need a DC jack, an SD card reader module, the step motor driver, some MOSFETs, connectors, buttons and the small components. Check the schematic and the full part list on my website. First I solder the DC jack and the power regulation part. Then I connect 12 volts at the input and check the voltages for 5 volts and 3.3 volts. If that is okay, I solder the ESP32, the buttons and the pull-ups so I could test if it works. Once it's soldered, on the side we have this UART port. I connect an FTDI programmer and upload the test catch for the TFT display. I also add the connector and I connect the display PCB to this main PCB. In order to see something, I have to place a light behind the display, because now it doesn't have the backlight anymore. But look, we can see the example code, so both the ESP and the display are working properly. Next we add the MOSFETs for controlling the UV light. Then as you can see, this PCB has 4 pads here. And on this I have to solder some male pins like this. And on top I will place the UV LEDs board. Like that we have some free space in between, so the PCB could act as a heat sink. I upload another code and I check if I can turn on and off the LEDs, with 12 volts from my power supply. I apply power and the LED board is now blinking. But now, unfortunately, I've made a very bad mistake. I've used the pins 39, 34 and 35 for controlling the step motor driver. And because I'm not yet 100% familiar with the ESP32, well, those pins can only be set as inputs, so we can't test the stepper driver. So we can't finish the printer for today, but at least we know that the display and the light are working. I will have to change the board and order it once again. But anyway, once I have the board, this will be the connections. A stepper motor would be connected to the main board on these pins. An end-stop switch like this one would be connected here. The buttons PCB is connected to the main board here on these pads. And the screen PCB is also connected to the main board. The UV LEDs board just goes on top of the main board. We also need to add the SD card reader on these pins here. So now just to make a test, on my PC I open Chitubox software and I create a profile for my printer with the resolution and the size of my screen. I import an object. I slice it and when I save the result, I select export as a zip file. If I open that file, we can see each layer of the object. I copy all these pictures to an empty SD card. I add that card to the mainboard module. Now I run a test code and as you can see, we print the shapes on the screen. I also change the code and now each time I print a new picture, I also turn on the UV light, just as a printer would do. So now I know that the SD card reader and the display are working, so basically we would be ready to go, if the stepper driver would also be working as well. For this project I spent a few weeks designing the enclosure, but it's not perfect yet. It has the main case, the Z-axis tower, a small part for the stepper motor, and another smaller part for the buttons and the display. I've printed all these parts using PLA material and it took a few days to finish it. Inside of the main case the controller board will go like this. It's made in such a way that the LEDs will go exactly below the display. Then as you can see the case has this perimeter and here is where the LCD PCB will go like this. For the stepper motor I found this one that has directly a linear screw on it, so we don't need to add a coupler, so we save some space. And this motor will go on this smaller part with some M3 screws. And then this part will get sandwiched between the main case and the Z-axis tower part. And for the Z-axis part I bought this linear bearing slider. It will cost you just a few dollars, and it will get screwed in place on top of this printed part. And with the screen PCB on top, it will look like this. But unfortunately the rest should be for the next video because I haven't finished the design yet and we still have that small error on the PCB. On the other hand, for the printing table, I want to use this aluminum block and to add movement I want to use this ball connector so it could move freely in all directions for when you want to calibrate the first layer. We have a few more parts that we need to go over, but I will finish those on my next video, because this one is already too long, and I still have to finish a few parts. By then I will also have the final code, now that I know that all the parts are working. I also have to design the resin bath to work with those FAP films and to be water sealed. Something like this one. So what do you think? It looks promising or not? Comment your opinion below. And stay tuned for the next part where I hope that I will get to test it and print something with resin. I also need to fix some small errors, as for example, the SD card position is very bad. It's very difficult to reach the SD card reader, so maybe you will need to use some tweezers or something like that. I also want to make a protective transparent case out of acrylic and these red sheets, so we protect the resin inside from the light from the outside. So stay tuned for all that. Thanks again and see you later, guys. So guys, here I am in my workshop, another video that ended. I hope that you like it, and the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel, so thank you very much once again.